Hello, math students. Welcome back to Module 2, Rational Numbers, and we are starting Lesson 4. Lesson 4 is called Addition and Subtraction of Rational Numbers. I apologize. Addition and Subtraction of Rational Numbers. So remember, a rational number is any of those that we learned about on the number line activity where you guys put the numbers up on the number line activity. They're also any of the numbers that we learned about when we filled in our classification of rational numbers, where you had to fill in the dots of which one was a rational number. Our goal for today we are going to practice adding and subtracting rational numbers. The question that I want you to think about during the lesson is, what is a property that you could use to help making adding or subtracting rational numbers easier? Okay, something to think about. What is a property that could help us? All right, so this is basically a lesson where we've probably learned all of the information before, and so we're calling it things to remember instead of things to learn. And so what I would like you to know is, let's think back, are these the same? Prove it. So it's asking, is this expression the same as this expression? And we're supposed to prove it. So one thing that it says is you have 4 and then you're taking away 5.5. So if we remember, we can use the number line to help us with this, right? Okay, so let's say 0 is right here, and we always start at 0, and the first number that we're supposed to have is 4. So 1, 2, 3, 4. So here's 4 on the number line. Here's my arrow. Go up to 4. And now this says I'm going to take away 5 wholes and a half. So I'm going to start right here and start taking away. So that's 1, 2, 3, 4. Here's 5. And then halfway would be here. So the question is, where did I end up? Well, I know that this is 1, 2, 3, and 4. So this is -1, and this one is -2. So what is this space right here? And if you said -1.5, then you are correct, because look at it. Here's 0, here's -1, here's -2. What's halfway in between -1 and -2? If you said -1.5, then you are correct. So the answer, according to this problem right here, is 1.5. Okay, so now let's prove it over here. So we're going to try it a different way, and this time let's use chips. So it says that I have 4 positive chips. So 1, 2, 3, 4 positive chips. There they are. And then it says that I have 5.5 negative chips. So this is going to be funny because I've never seen a half of a chip, but we'll draw it anyway and you get the idea. Negative, 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 right? And so then, oh, that's only 4. I apologize. I have to draw one more because it says 5. 1, 2, 3, 4, 5.5. Okay. And now I have to make my 0 pairs. So 0 pair them up. So 0, 0, 0, and 0. What am I left with when I get all finished? If you said 1.5 negative, then you are correct, because that one's negative. This half is negative, so 1.5 negatives. So the question is, are they the same? Prove it. Did we prove it in 2 different ways? The answer is yes, we did. And are they the same? The answer is yes. Okay, so just a quick reminder that subtraction is exactly the same as adding. So notice we went from subtracting to adding. This is a positive 5.5. The opposite of positive 5.5 is negative 5.5. And so we remember that subtraction is the same as adding, the opposite. And it works with rational numbers as well. Okay, so let's try something else. It says rational number, rational number, sum. So a rational number, remember, is any of those things. So if you go back to our graphic organizer, remember it looked like this. This was all of our real numbers, right? And then we had a box over here that said rational, right? And then the box over here said irrational, right? And then we didn't have anything else on this side, but on this side we had whole numbers, we had integers, we had whole numbers, integers, and we had natural numbers, right? So that's what we had listed as rational numbers. So 4 is a rational number because it's a whole number and an integer and a natural number. So 4 is all of those, okay? Negative 5.5 is still a rational number because it can be written as a fraction. And it already is written as a fraction because remember, the definition of a rational number is any number written as a fraction. Is this a fraction right here? Yes, it's a fraction. It's actually a mixed number, okay? And so it is a rational number. So I'm going to take the rational number 4 plus the rational number negative 5.5, and I should get the sum, which is negative 1.5. And the reason we know that is because we proved them up there already. So then go down here, and it says the opposite of the sum, this is the sum right here. The opposite of the sum, what would be the opposite of negative 1.5? 1.5, do you see it? So the opposite of the sum, so this one becomes a positive 1.5 because that's the opposite. The opposite of the sum is the sum of its opposites. Okay, so look what happened right here. This was a 4. What is the opposite of 4? Negative 4. This was a negative 5.5. What did this become? A positive 5.5. And the opposite of negative 1.5 is the sum is a positive 1.5. Okay, so it's kind of interesting. If you take everything's opposite, then it will still be a true math sentence, basically. So if we have 4 plus a negative 5.5, the answer that we get will be a negative 1.5. But if we have a negative 4 plus 5.5, then the answer will be a positive 1.5. Okay, so read it again. The opposite of the sum equals the sum, add them together, of its opposites. Opposites. Okay, so that's kind of interesting. Using the opposite of the sum is the sum of its opposites. Can you make, let's see, adding and subtracting rational numbers easier? Well, let's try it. So we have 7 plus a negative 9 or a negative 9 plus 7. The answer is we did exactly what they said, right? And so what you're going to do is figure out which one looks easier. So for me, if I see 7 positives plus 9 negatives, or I see 9 negatives plus 7 positives, it just depends truly on what your preference is. For this one, if I saw this problem like this, my initial thought is I'm going to use the chip method. So 1, 2, 3, 4, 5, 6, 7. These are all positives because I have a positive 7, right? This one is negative, so I'm going to draw 9 negatives. So 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all negatives. And then I remember to do my 0 pair business. 0 pair, 0 pair, 0 pair, 0 pair, 0 pair, 0 pair, 0 pair. So what am I left with? I'm left with an negative 2 as that answer. Okay, but when I see it right here, what naturally my brain wants to do is, oh, jump on a number line. Okay, so then this one over here is going to be 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. So negative 9 sits right here. So I go down to negative 9 because that's what I have. And then I'm adding 7. So I go 1, 2, 3, 4, 5, 6, 7. I stop right here. And what number do I end up on? Negative 2. Okay, so easier. Which problem looks easier? It all depends on what tool you want to use. If you want to use the chips, it's the same as using the number lines for the other one. So again, the whole thing that you've got to recognize about making rational numbers, adding rational numbers easier, is just what works the best for you. Okay? All right, as long as you're adding, you can use the commutative property to make a problem easier because changing the order of the number does not change the answer. The only thing that you have to be really careful with the commutative property is when you're changing the orders of the numbers, you have to know what your numbers are. So for example, right here, this is a negative 8. This is a positive 4. So if we wanted to use the commutative property, then I have to say that it could be 4 plus a negative 8. You have to talk about the numbers that you're moving, not just the signs that you're moving, the numbers that you're moving. So now let's test it. This one says negative 8 plus 4. So I'm going to say 0 is over here. 1, 2, 3, 4, 5, 6, 7, 8. This is negative 8. Always start at 0, go down to negative 8. Now it says to add 4 positives. So I go 1, 2, 3, 4. And I end up right here, which happens to be negative 1, negative 2, negative 3, negative 4. So that's that answer. And then over here, it says I have 4 positives, 1, 2, 3, 4, and I have 8 negatives, 1, 2, 3, 4, 5, 6, 7, 8. Those are all negatives. Circle up my 0 pairs, and I'm left with negative 4s. Okay? So they are the exact same problem, just depending on what you're doing. So the property that can be used to help you is the commutative property. Just change the order of what you're doing. Okay? So now we did the opposite of the sum on the other page. Let's go ahead and do this one. I have 2 negatives, 1, 2, and then I'm adding on 7 more negatives, 1, 2, 3, 4, 5, 6, 7, negative, 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 and that gives me an answer of 1, 2, 3, 4, 5, 6, 7, 8, 9. So this answer right here is negative 9. Then it says that I can do the opposite of the sum. So remember, the opposite of the sum, so that would be 9 equals, what is the opposite of 7? Or excuse me, the opposite of negative 7 is 7 plus, what is the opposite of negative 2? 2. So does 7 plus 2 equal 9? Well, of course it does. 1, 2 positives, 3, 4, 5, 6, 7, 8, 9. And that's how I prove that the opposite of the sum works. Okay? So that one's kind of cool too. All right, so now the last one that we have to try. You can use whatever method you want. What I would highly suggest you to pay attention to, though, because you have a mixed number right here, for me, I'm going the number line, because it's a lot easier to show this on a number line than it is to try to cut chips up. So it says that I have 6 1/4. So I have 1, 2, 3, 4, 5, 6 1/4. So I have to go all the way to 7. So 6 is here, and 1/4 would be about here. Yes. So that's 6 1/4. Okay. So I'm starting right here. So start at 0, go up to 6 1/4, which is right there. Now I'm having to take away 5 wholes. So from here to here would be 1, because that's 1/4. From here to here would be 2, 3, 4, 5. So I stop right here. And where am I? I am at 1, because this is a 1 right here. This is a 2, this is a 3, this is a 4, this is a 5, right? If I stop right here, look at where I'm at. I'm at 1 and what? 1/4. So the answer is 1 1/4. Okay? And so if you have 6 1/4 and you're taking away 5 of them, then the answer that you would get is 1 1/4. Okay? So again, whenever I am using fractions, it's a lot easier to draw the number line, and when I'm using integers, it's a lot easier to use the chip model, just depending on which one you prefer. Okay, let's go back to our goal. Our goal says today we are going to practice adding and subtracting rational numbers, which is what we did. All of these are rational numbers because of our little review of what rational numbers are. The question is, what is a property that you could use to help making adding or subtracting rational numbers easier? And we proved it by doing some. The property is the commutative property. Change the order, and you still come up with the exact same answer. All right? Okay, kiddos, that's all I have for you in this lesson. Talk to you soon. Bye.